How long today do we have to turn this?
I will be in my office from 11 to 1:30.
Okay.
And 2:40 to 4.
Okay, perfect. Will your office be like unlocked in this room or just?
No.
Okay, that's fine. 2 to 4, you said?
Now, if you, I don't even know if it's gonna be open. If you have to come in between during exterior, you can turn it into the main office, which is the glass windows across from the lab area.
Okay, is that like where your fundamental issue kind of permanent lessons?
Some people do.
Okay, I think I did.
Okay, I don't know who did what. But if you do that, then you got to put your shoes in my mail.
Okay. I'll need that. So I'll tell you.
What is today, the 13th? Yes. And I just,
Beyond.
I have half my class.
They won't be able to register without.
It is. I'm not. Just, that's been part of the course that only half the class, except on test days. I'm like. It does not say. Like I have a ghost. I do need that for today. Trying to make sure I have everything I need. If you are missing picking up anything, come grab it. I have tests and labs and the music and chemistry bonus. On the test.
Oh, the music. The English chemistry as well.
Just so you can see, I did. Thank you. We didn't turn it in there. No.
Yeah.
Thank you so much.
Next one. You might not. I don't even know what we're getting.
Well, that's what that does. I'm just passing back everything that people have been missing. Trying to keep up with y'all. Trying to clean up my desk. Now. I'll announce that.
Okay, folks. So here is the current. Number one, today in class, I will finish up bond polarity. We will then go into formula mass versus molar mass and introduce Avogadro's number. And then we will get into balancing chemical equations. In other words, this book, besides chapter 1, has really been designed so that it gave you all this information about the atom of the element. How many protons did it have? What's its atomic number? How many electrons in a neutral atom of an element? What's the isotope? How did we get the average atomic mass? Where are all the electrons located? It spends the first portion of this, I should say college Chem 1, describing the atom of the element. Then we let these atoms of the element start reacting to form compounds. And the next portion of this course has been all about those compounds. We discussed electron configurations and how they change in the formation of an ion. We let those ions come together to make ionic compounds. And we talked about the Lewis structures of those ionic compounds. We talked about covalent molecules, which arise through the sharing of electrons between two atomic nuclei. And we talked about the names and formulas of those covalent molecules, as well as discussing their Lewis dot structure. In introducing those covalent molecules, some other things came into play, like single bonds, double bonds, triple bonds. And we had to spend a couple of minutes to talk about the strength of those and the length of those. Some other things that came into play, which we are talking about now, is the fact that covalent bonds, when you think about a covalent bond, especially when you're drawing them in a Lewis structure, we just draw a line between the atoms, and that suggests that these electrons are shared the same, but they're not, which is what we're going to pick up with today. And we got to finish our conversation about these compounds with their formula mass and molar mass. Then we finally get to start talking about them undergoing reactions. And we finally get into the chemical process where we combine compounds to make new compounds. So that's how this book has really been designed, is this constant building up of the chemistry. The reason is the same reason we do stuff in grade school. We start out in kindergarten learning our alphabet and learning to draw our letters. Then we start combining those letters to form words. And then those words start to make sentences. Well, the same thing has been going on all along in chemistry. We started with our alphabet. And then we let that alphabet combine towards the end of class, we're going to start letting our compounds combine to form sentences called balanced chemical reactions. So we've just been building just like you do any language. We've been building up a language. So that is what we're going to do today in class. Now, I've been asked, okay, you got a bonus, it's due today, when are you in your office? I will be in my office immediately after class today until 1:30. I have a meeting at X period that I've got to go to. And then at the end of X period, I'll be back in my office till 4. So for 2:40 to 5, 2:40 to 4. Now, sometimes the issue with waiting till the last minute is actually getting a hold of me. I understand this. If for some reason you have to come during X period, you can drop off the canned goods or the food items in the main office. So when you're up on the second floor, there's an office that is nothing but glass windows. You can drop it off in there, but you have to put your form in my mailbox, and they'll point toward the mailbox if you ask the person in there. So you can, but please, 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 if at all possible, if you can get to me when I'm in my office, I would prefer that. Now, Tuesday, as per always, you want to be here on time. Because guess what's the first thing I'm going to probably do Tuesday? I'm gonna have the exam with me, and I can go over what to expect on it. And so, yes, you want to be here. And then we're going to start dealing with some, we're going to be using our balanced chemical equations for some calculations. That is the goal. You do have lots due on Tuesday. You have 7 things due Tuesday. There are 5 Ed Puzzle videos. 1 over ionic compounds, 1 over linear, 1 over trigonal planar, and 1 over linear and trigonal planar, 1 over tetrahedral, 1 over trigonal bipyramidal, and 1 over octahedral. There is also a Blackboard quiz that requires you to apply all of that knowledge from Lewis structures and Vesper theory and valence bond theory and molecular polarity. That is due. And then finally, there's a homework due. Now, if I were you, the order I would do things in is I'd watch the videos first. Just so you get a little bit more visual information on how to perform it, and hopefully after you see it enough, it starts to click. Then I would do the homework. Because again, you're going to get a lot more practice. And then finally, I would do the Blackboard quiz. So if I had an order to do things in, that's the order I would do it in. Just to give myself as much hope before I get to the Blackboard quiz. Now, every single thing, whether it's the videos, whether it's the homework, whether it's the Blackboard quiz, I did give you 2 chances to do it. So if you don't like your grade, you still got another opportunity to do it. The biggest issue with the Blackboard quiz, and the reason I'm saying I'm gonna do the homework before the Blackboard quiz, is because the homework does a couple of different things. As you well know, the homework, if you get it wrong, it gives you some information. Number two, with the homework, you're able to do some of the questions and take a break. Do some more questions and take a break. And it doesn't matter because you can come back to it anytime. You do one question at a time. On the Blackboard quiz, it's going to give you all 60 questions at one time, and you have to do all 60 questions in one sitting. Now, I've given you 240 minutes, so I'm giving you 3 hours to do it. But still, you have to do it all in one sitting. And so that's why I recommend the homework before I do the quiz. Simply because the quiz, once you start it, you've got to finish it. And you can't take, I mean, you can take breaks, but you still have only a 3-hour time frame. And that's assuming your computer stays connected and all that jazz. Questions for me? What, is there a quiz today? Yes, there's a quiz today. Yes.
The Blackboard quiz, is that not open until Tuesday, or is all of that open now?
I believe it's all open now. So that you can do it at any time. Because I know if I made you wait until Tuesday, that's a lot in one day. It's not like the quizzes, the active quizzes, I keep them rather short. And so I don't mind putting it all in one day. But because of the fact that I know it's long, sometimes you have more time on the weekend. And so I wanted to give you the opportunity to take it when you could.
Where can we find the videos in Blackboard?
There should be an extra folder in this week's Blackboard page. And it has, I think it says Ed Puzzle and Blackboard quiz. Other questions? Folks, I know that I want to explain a couple of things as to why you have all these Ed Puzzle videos and Blackboard quiz. You've had 3 lab lectures. You get 25 points for just attending the lab lecture. As long as you attended one, you're going to get your 25 points, because I realized during the ice, some people weren't able to log in. So as long as you attended one of them, you get your 25 points. Your 5 Ed Puzzles counts as 1 lab grade, essentially. And your Blackboard quiz counts as a total lab grade as well. So that's why they're there. That, and I just know this material takes practice. It is not something you can do 2 days before the test and survive. This one takes more practice than a lot of things. So that's the other reason. I may have given you more information than you wanted to know. There is a method. Okay. Any questions for me before I get started? Yes. None of it has been put into Blackboard yet. The only one I can put in there is the 25 points from the lecture.
The other you have to earn due to the Ed Puzzle quizzes and the Blackboard quiz. So those may show up, but they haven't been finalized yet. Other questions? Just think, starting next week, we go back to lab as normal. I'm excited. Okay. Making sure I don't have any questions. Then let's get started. So we talked about the fact that even though we represent covalent bonds as sticks between two atoms, and it's always between those atoms, doesn't mean they're shared evenly. So on towards the end of Tuesday, we talked about the fact that the electronegativity, what it's really describing is how much time an electron is going to spend around that particular atom. The higher the electronegativity, the more time the electrons in the bond spend around that atom. So if you have fluorine in a bond, because fluorine is the absolute most electronegative atom on the entire periodic table, it means that the electrons love spending time with fluorine. And so they're going to pull the electrons away from the other atom. This creates a polarity because, and I think I gave you as one of the examples, hydrogen and fluorine. The electrons spend very little time around hydrogen and a lot of time around fluorine. Now, what charge does an electron have? Negative. So since the electrons are spending so much time around fluorine, it winds up being a partial negative on the fluorine. And since they are pulled away from the hydrogen, that winds up making hydrogen partial or partially positive. Now, the way we represent this partiality is using the Greek letter delta, the small delta, which to me looks a lot like an S. And if it's partial negative, we put a delta S negative. If it's partial positive, then we put a delta S positive. And knowing my thing, it's going to change it. But it's supposed to be a delta. A small delta. The other way we represent these bonds is we represent them with a dipole moment. Let's break this word down for a moment. Dipole. Di means what? Two poles. You got a positive and you got a negative pole. In a magnet, you got a positive and you got a negative pole. Now, the dipole moment is illustrated with an arrow, which I've already shown you. And that arrow always is going to have the head of the arrow point towards the negative, the partial negative.
And on the opposite end of that arrow, it's going to have the fletching. In this case, it looks like a positive sign. Positive end gets a positive sign. The head of the arrow points towards the negative. So to represent this molecule, we can draw a dipole moment arrow in the direction of the fluorine. Okay, so what are our possibilities with these electronegativities? What are the possibilities that we might encounter? Well, you can have what on my homework is a pure covalent bond. What it means is that the change in electronegativities between the two atoms is equal to 0. So in other words, if you take boron and arsenic, they both have an electronegativity of 2. Therefore, those are going to be shared perfectly evenly. Now, you also can have a nonpolar covalent bond. And when you have a non-polar covalent bond, the change in electronegativity is going to be equal 0.1 to 0.4. Basically, this means there is a slight disproportionate sharing of electrons. For active folks, they don't have a pure covalent, but they do have a nonpolar covalent. They also have a polar covalent. A polar covalent bond would have a difference of electronegativity of 0.5 to 1.9. Means that these elements disproportionately share those electrons. It is with this one that a dipole moment arrow is typically required. And again, you will see this as a possibility on active. Finally, you have ionic. Technically, ionic is a difference in electronegativity of anything from 2 to 4, or a metal, non-metal bond. This means when you have an ionic bond, it means that the electrons are not shared at all. It means that the electrons are transferred from the cation to the anion. And you might see ionic on active. You will need to know what these differences in electronegativity. You will need to know essentially this column and what it means. So I guess these two columns. So let's look at some examples. If I have a bond between iron and chlorine, what kind is it? It's ionic. How about sulfur and chlorine? Well, the way you figure that out is that means you have an S and a Cl. The electronegativity for sulfur is 2.5. The electronegativity for chlorine is 3.0. The difference in electronegativity is 3 minus 2.5, or in other words, it's 0.5. Since it's 0.5, that makes this bond polar, covalent. And since it is polar covalent, that means you need to draw the dipole moment arrow. The head of the arrow is going to point towards the more electronegative atom, with the plus on the other end, or the fletching on the other end. Just to help you out, carbon has an electronegativity of 2.5. Hydrogen has an electronegativity of 2.1.
Do you want us to say what it is?
What is it? It's nonpolar covalent. The reason it is nonpolar covalent is because delta En is 2.5 minus 2.1, which means it's 0.4, and therefore it falls under nonpolar covalent. Now, I want to take a moment and actually do a couple of things before we get into the next piece. Number one, I went over molecule polarity first for a reason. And that is because you can have a polar bond, but the molecule not be polar. And I didn't want you to confuse the two. Again, you can have a polar bond, you can have a sulfur chlorine bond, but the molecule itself be nonpolar. That's why on a molecule, you have to look and see, is there a direction that the electronegativities are steadily increasing in on the molecule? If so, then that can mean it's polar. So again, I did molecule polarity first because I don't want the two confused. You can have a molecule that is nonpolar and have polar bonds. There's more to molecule polarity than just what the bonds have. Questions? That's all there is to bond polarity. It's probably one of the easier things that we've done. Yes, you will get this table of electronegativities on your test. I don't make you memorize them. I don't make you just go off of trends. I actually give you the table of electronegativities. So, okay. So the next thing we are going to do is we're going to start to finish up our discussion about compounds. Specifically, we're going to get into the difference between formula mass and molar mass. But before I get into formula mass and molar mass and what the difference between these two are, I did want to just describe, because it is directly related to compound, the sheet that is not a diagram. I can't remember if I gave you this or not. I don't think I did. But this is another way to figure out whether you have an ionic compound, covalent molecule, or an acid. And then how to name them and how to develop the formulas. So I thought this sheet may be useful And so I wanted you to have that, even though we're not gonna go over naming and formulas again. I thought this sheet might be useful when you're preparing for the exam. Ugh. Any questions so far today? Starting now, which this class is usually pretty good about. A calculator is a must. There is only one more section that will not require a calculator. Everything else requires a calculator. So from now on, a calculator is a must. So let's finish our discussion about compounds. Just the compound itself with the formula mass and molar mass. Back when we talked about the atoms of the elements, I introduced this concept of an isotope. An isotope, or a pair of isotopes, is going to be an element that has the same number of protons, but differs in the number of neutrons. Another thing that we learned about the isotopes is that the average atomic masses found on the periodic table are the result of, or is a weighted average of all naturally occurring isotopes of an element. So if I have oxygen, we said that its average atomic mass according to that periodic table at least, is 15.9994 atomic mass units. Now, we cannot measure atomic mass units. We can't measure atomic mass units because this is for one atom, and we can't physically manipulate one atom at a time. It's only been in the last 20 years that we've been able to see a single atom. And that takes an instrument that is extremely high powered to even be able to see it. We don't have a tool that can manipulate one atom at a time. So we needed something else. An individual named Avogadro came up with a way for us to be able to work with
these substances. And that is, instead of one atom, let's have 6.022 times 10 to the 23rd atoms. And if we have 6.022 times 10 to the 23rd atoms of oxygen, now it is 15.9994 grams. We can physically go up and measure 15.9994 grams. Now, 6.022 times 10 to the 23rd of anything is equal to a mole of that thing. So if I have 6.022 times 10 to the 23rd atoms, that means I have 1 mole of atoms. And if 6.022 times 10 to the 23rd is equal to 15.9994 grams, that means that that is worth 1 mole of oxygen. So, formula mass will be in atomic mass units. And it will be for a single atom or molecule. Molar mass will be in grams per mole. And it will be for 6.022 times 10 to the 23rd atoms or formula units. That's the difference between an atomic mass and a molar mass. One is for just 1. The other is for 6.022 times 10 to the 23rd. Now, folks, it's hard to imagine what 6.022 times 10 to the 23rd looks like. That's a monstrous number. Well, just how monstrous is that number? If I'm talking about 6.022 times 10 to the 23rd marbles, little marbles, the entire mainland United States is going to be covered 70 feet high. If I talk about 6.022 times 10 to the 23rd P's, every planet and a couple of Saturn's moons are going to be covered in a layer of P's. 6.022 times 10 to the 23rd is a huge number. But when you're talking about something so microscopic as atoms, we can measure that in grams. We can go upstairs and use the balances to get to 6.022 times 10 to the 23rd. Okay. So, if I have carbon and I have one atom of carbon, I'm going to be talking about its formula mass. And that's going to be 12.011 atomic mass units. But if I talk about the molar mass, again, that's going to be 6.022 times 10 to the 23rd atoms of carbon. And it's going to be 12.011 grams is equal to 1 mole. Now you're going to see this written a couple of different ways. I like the 12.011 grams equals 1 mole because we're going to be using it as a conversion factor later on. And it helps to see it in that format. However, you can also write 12.00011 grams per mole, and it means the same thing. Now, there's the law of mass conservation. That says mass cannot be created nor destroyed. What that means is following the law of mass conservation, is that every atom of an element brings with it its own mass when making compounds. So let's take sodium chloride. According to the periodic table, it's 22 point something, but basically it rounds to 23. I'm gonna have to do a little bit of rounding up there. Just wait, no, I don't. I have the periodic table with me. 22.99. So one sodium carries with it its 22.99 atomic mass units. And one chlorine carries with it its 35.45 atomic mass units. So the sodium contributes 22.99, the chlorine 35.45. So sodium chloride has a mass of 58.44 AMUs. Now, just like we were talking for atoms of an element, this would be its formula mass because we're dealing with a single formula unit. we were dealing with one sodium atom and one chlorine atom. But now, to get its molar mass, we're going to have a mole of the formula unit. Meaning we are bringing in 1 mole of sodium and 1 mole of chlorine. Now, just like we were talking before, when we're dealing with 1 mole of sodium, it's going to have the same numerical value, but it's going to have a different unit. For chlorine, it's going to have the same numerical value, but it's going to have a different unit. So if we're talking about sodium chloride, and we're talking about its molar mass, it would be 58.44 grams per mole. That's all there is to formula mass and molar mass. Formula mass is for one of them. It's going to have the units of atomic mass unit. Molar mass is for 6.022 times 10 to the 23rd of them. And it's going to have the unit of grams per mole. Yes.
Is this on the next exam?
This will be on the next exam. This will be where the next exam ends. So yes, I'm glad you asked that. Exam 4 starts here. Yes.
So, formula mass and molar mass will be on the third.
It'll be on the 3rd exam next Thursday. Basically, folks, the 3rd exam is all about the compound. How do you name it? How do you write the formula? How do you draw it with Lewis structure? How do you determine the compound's the hybridization of the central atom? How do you determine the polarity of the molecule? How do you determine the molar mass? It's all about the compound. So the next test is all about the compound.
So everything on the active, like the 82 questions, that's all like just examples for the next test?
Pretty much. It's more practice. My goal is, folks, I know these last 2 homeworks, and most of the homeworks have not been near as long. And I don't expect most of the homeworks going forward to be near as long. I realize these last 2 homeworks, the one that was due Tuesday and the one that's due next Tuesday, are long. It is because the only way to learn this material is to practice it. So I've given you a lot more practice in hopes that you can solidify your understanding of this material. But from now on, with all the math, it'll be shorter again. Okay. So now we get to write sentences. or chemical reactions? A balanced chemical reaction is necessary in order to follow the law of mass conservation. Again, this law of mass conservation says that matter or mass cannot be created, nor can it be destroyed. Therefore, if you start with sodium, you got to end with sodium. If you start with 2 sodiums, you got to end with 2 sodiums because they carry their own mass with them. Now, the general structure is going to have the reactants followed by an arrow to the products. The reactants are your starting materials. The products are the resulting materials or ending materials. The arrow means yields, produces, or some term that is similar, or it can mean equal in the case of the balanced reaction. By the way, I tend to shorten reaction to RXN. So if you see me write RXN, that's the same as reaction. Now the process for balancing a chemical reaction. Balancing a chemical reaction is very much, to me, like a puzzle. Meaning, I can't give you specific directions as to how to do it. I can give you hints. But when I balance a chemical reaction, sometimes I get it on the first try. Sometimes it takes me 3 and 4 tries. It's kind of like a puzzle. Sometimes you fit the piece in, no problem. Other times it takes you a while. Now, the hints, if you will. Number one, make a list of the elements in the reaction. Now, when I'm doing this, if a polyatomic ion appears on the reactant side, and product side, then keep it as a unit. Two, list the quantities of each element on the reactant side. Then list the quantities of each element on the product side. Adjust the quantities so that you have equivalent amounts by multiplying formulas by coefficients. When you're doing this step, you're going to start with elements that appear in only one reactant and in only one product first. And you're going to save compounds that consist of only one type of element until last. Step number 5, is to review the balanced equation to determine if the coefficients are in the smallest whole number ratio possible. If not, you will need to divide to get it to that point. Because balanced chemical equations are always in the lowest whole number ratio possible. Okay. I don't have time to balance a chemical equation. So we will pick up with balancing chemical equations, and then we're going to start doing math with these formulas and balanced chemical equations starting on Tuesday before your test on Thursday. Thank you. Yes. On Monday, I will be in my office from 11:30 to 4. I'll go after X period, so I'll be there until 4.
I got 2 things. First, not Tuesday, but like the Thursday before that. I think it was that day. Did